We have I'm on page 133, by the way. We have a test tomorrow and Friday. And rather than me printing up two separate packets, you're going to get the entire test tomorrow, and then you also have Friday to work on it. Does that make sense?
Yes.
Like, you'll turn it in at the end of tomorrow, at the end of class, and then I'll hand it back out to you on Friday. Seem okay so far? And you get a full sheet of paper. Hopefully this is not the first time you've realized that. All right. So page 133, about halfway down, says, I survey 300 people to see whether they plan to vote in this year's election. So for number 10, what do you think the sample is? It says, I survey 300 people to see whether they plan to vote in this year's election. Well, I think our sample would be registered voters, even though it doesn't say it. Okay. What is the variable being measured? Vote. Name two types of displays appropriate for qualitative data. All right. This is what I need help on. You guys are way smarter than me. Qualitative data. There's two different types of things. What do you think? Laura knows.
Probably.
Yeah, see? Qualitative data, okay? Go back to in the beginning of the book. What does it say? What do you know? It's in the book. Yeah.
Data that's like observations.
Observations?
Not like it's like observations.
Observations, you say? But not numbers?
Yeah.
Okay. Maybe. I like. What do you got?
Names.
Names? What page you on? Did you look at back at it? Oh, cool. Go ahead. What else do you see on your worksheet?
I just put categorical and labels.
Categories? Labels. I like it. Yeah, this I went through the test yesterday, and so I decided I'll just put it all together as one test. So when you're taking the test, it'll say congratulations, you're done with part one. That doesn't mean you're necessarily done. Just keep going at your pace. Work along with it. There will be some students that might get it almost completely done tomorrow, but you'll have 2 days to do it. Okay. But some of the questions just jump out randomly at you, and it's like, oh wait, what are qualitative? So make sure you have those definitions. Make sure you have the qualitative, quantitative. Make sure you have the discrete, continuous. Make sure you have the nominal, ordinal, and scale. Have those definitions down. Okay. Number 13. Name a couple of key differences between a histogram and a bar chart. So histogram versus bar chart. I'll show you kind of the difference when this would be a histogram, and this would be a bar chart. Okay, so the widths are the same of all of our bars, but usually on a histogram or on a bar chart, you have some sort of categories down here. But these aren't categories down here, so tell me something else about a histogram that you might know. Bless you. Yes. What else? Do I have to look back for you? Yeah, do it for us. All right. And again, I'm sorry that so a bar chart display, let's see. So a bar graph sometimes shows distinct bars for each category with the height of the bars showing the relative frequency of results. So on this, you would have results. Okay, so this could be like A, B, and C. whatever A, B, and C are. And then the histogram. So just so you know, the bar chart stuff I found on page 4. And then the histogram says a well-constructed histogram is easy to follow and represents data fairly. A histogram should contain each of the following features. Clear tick marks on the labels on both the axes. The width should be identical. The vertical axis should begin with 0. The area of each bar must be proportional to the raw data count. The bars should touch. Arguably, it helps us visualize left to right flow of the data. Unlike bar graph, the order of the bars is important. For example, we can see that we have several peak in this particular thing. Understanding the final scores distributed. So histogram information would be on page 7. So I think it would be important that you know that page 4 and page 7, have the difference between those two on, again, your sheet of paper. I'm on page 133 if you just came in. Number 14, 2 quantitative displays maintain. Name 2 quantitative displays that do not maintain the entire data set. What 2? So let's think about this. Would a dot plot have all of our data dotted? I think so. Okay. Would a pie chart, remember pie chart is percents, that would have all the data represented, but it's going to be represented in percents. What a bar graph? So remember, we'd have labels here, A, B, and C. And then the amount. So I think you would have all of your data there. What about a box plot? Would a box plot have all the data displayed? Being you can do a box plot and make an entire box plot based on a 5-number summary. So would a box plot have all the data in it? Think about it. If I could make a box plot, if I had 200,000 pieces of data, and then next to that 200,000 pieces of data, it said, here's the 5-number summary. Yeah, this won't. You don't need all of your data to work on a box plot. Okay, does that make sense? Again, if I give you a 5-number summary, and that 5-number summary represents 200,000 pieces of data, and you didn't have to plug the 200,000 pieces of data in, thank goodness. It's just not going to maintain it, and that's okay. All right, and there's one other. What else doesn't maintain it? We have a histogram here. Would all our data fit in there? What do you think? Yeah. Yeah. Can't really, you can't see it, right? Huh. I don't know. I'm trying to think. What would not show all of the data? So pie chart, histogram. Let's see. Many bars. There is no easy answer. 2 bars. Histogram says histogram is one of many data displays for quantitative variables. That's what we have. It consists of bars equal to it represents the range among the variants. So this won't show it either. Okay? And the reason it won't show it is you have a range from like 0 to 10, and then to 20, and then to 30, and then to 40. And then you're just counting up how much is in each, but it doesn't necessarily show you the exact data. It just says, from 0 to 10, we had 4 scores that happened to be 0 to 10. Well, what were the scores? What were they between 0 to 10? What was the exact scores? I don't know. So histogram and box plot will not maintain the data as far as the display goes. And then okay, so those won't, but what ones will? 2 quantitative data things. So this, the dot plot, it does maintain the data. Okay? And I'd say the pie chart would also work. Okay? All right. Now we're down. Oh, the best kind of questions ever for math. True, false. How many of you always wanted to have a true, false test given in math, and then all of a sudden you have a true, false test given, and you're like, that test sucked. All right. Is the median, so number 17, is the median a measure of spread? No, it's the middle data point, right? It's not. So if it said if the median was a central measure, something like that, that would work. But if it's a measure of spread, no, the median doesn't tell us how far out the data goes. Standard deviation is a resistant measure, meaning standard deviation, does standard deviation go with mean or median? Standard deviation go with mean or median? Goes with the mean, right? So can the mean be impacted by outliers? Yes. So that means the standard deviation can also, so standard deviation is not resistant to outliers. Okay. Number 19, it is impossible for standard deviation to be a negative number. That's totally true, because in the formula for it, you are taking a quantity, you might be subtracting stuff, but each quantity gets squared, and if you square something negative, it becomes positive. The IQR is the width of the middle 75% of the data. IQR 75%? What do you think? Q3, Q1. So think of your box and whiskers. It is false. So you have 25% here, 25% here, 25% here, and 25% here. The IQR is this. Yeah, it's the middle 50%. Okay? So IQR maintains 50% of your data. Outliers should be removed from the data when found. Should we just ignore outliers? That's really bad statistics, friends. Do not, if you have outliers, are taking place. They are part of data. It's you eliminating outliers doesn't mean you are now a better statistician. Okay? Outliers do indeed take place. And again, think about the outliers when I had a bark at the city of Centennial when they were running traffic patterns in my neighborhood, seeing how fast people were driving. And then they send me the data and say, this is what our data shows. And then I run the data and I'm like, this guy's wrong. And then I got the city engineer to admit that he cast out the outliers. It's like, that's not how you do it. And all of a sudden they put up the flashing school zone sign because I'm that neighbor. I'm not quite the neighbor of get off my lawn, but I'm that neighbor. All right. Number 22, you can find the mean of data. You can find the mean of data set from the box plot. Can I find the mean in that box plot? Well, that's the median. No, we can't find the mean. We can see approximately where it's going to fall, but I can't give you the exact value of the mean. Okay? So 22 is false. If you score at the 45th percentile on a test, this means that 45% of the class scored higher than you. No, 45% scored lower than you. So 23, make sure you understand a percentile. You're always talking to the left about where you score. So 23, if you scored in the 45th percentile, you did better than 45% of your class. Number 24, in uniform rectangular distribution, each possible outcome occurs equally. Yes, true. Number 25, in a skewed left distribution, most of the results occur on the high end with some results trailing off below that. So skewed left looks like this. So if it's skew left, most of the results occur at the high end with some results trailing off below that. I guess that could happen because you could have all your results here and then you have a couple here. Yeah, I think that would be true for 25. And then 26, in a symmetric distribution, the mean will be equal to the median. Well, symmetric means it's normal, so that is true. Symmetric and normal go hand in hand. 27 on page 134, you wish to create a chart of the ethnic breakdown of firefighters nationwide. Which chart would be the most appropriate? So ethnic backgrounds, again, you want to look at a visual thing. So a histogram, you'd go 0 to 10. No, that's not going to work. Box plot, no, that's not going to work. Stem plot. Maybe a box plot would work. So the box plot, you're doing this. So they're all separated. So you have, A, B, and C, different nationalities. So you could count that. I think that would work. I think the box plot, but I also think that you could argue that a pie graph would work as well. But with the pie graph, you just have to make sure you break down percentages. Okay? I think they would both work, so I think you could have 2 correct answers. If you answer one of the answers correct on the test, I'll give it to you. There's a couple of them that 2 answers will work. If you give me one of them, you're good. Number 28, a baseball pitcher records the speed of his fastball. Which of the following would provide evidence that this pitcher throws pitches at a certain consistent speed? So his mean speed, so his average speed of throwing the fastball is very high. His average speed or his mean speed throwing the fastball is very low. His standard deviation of fastball speeds is very high. The standard deviation of fastballs is very low. So what's going to keep you consistent? Having high and low speeds is not going to help us. It has to do with the standard deviation. So the standard deviation, if it's a big number, it's really wide. If it's a smaller number, it's closer together. So the answer, he would have to have a low standard deviation. And the lower the standard deviation, and again, the standard deviation basically works like this. So the closer and closer this region gets together means the more consistent something's going to take place. Okay? Like if you keep throwing, if you have a range between throwing 80 and 90 miles per hour, you know that your pitcher is going to throw between 80 and 90 miles per hour. But if you have the one kid who goes from 60 to 100, that's a much bigger range. So the bigger the range as far as the standard deviation goes means the less consistent something is. And then number 29, the term resistant refers to, in statistics, the statistic resists change when more data is added. The statistic maintains its value even in small data sets. The statistic resists being influenced by outliers. Anybody? Yeah, it's letter C. The outliers. So the median and the IQR do not get affected by outliers. The mean and the standard deviation do. Okay? So my friends, again, this test tomorrow, I'm going to give it to you, and you're like, oh my gosh, this is huge. Yeah, photocopied rather than having going, here's part 1, part 2. You're getting the whole thing tomorrow. Do as much as you can tomorrow. And then on Friday, finish it up. And of course, you need more time. But then that's all I got for you.